Hey guys, week 5, confidence intervals between two means. Woot! Um, so in last week we talked about confidence intervals between two proportions. Today we're going to look at the one about two means. So these are talking about averages. They're a lot more fun, slightly easier. Let's go ahead and look at what we need to know. So the first thing that we need to know is state. Because we're just going to continue with state, plan, do, conclude all day long. Now, whenever we're doing our null and alternative hypothesis, we are going to be using mu because mu is the a population mean. So we're saying that the population mean of whatever the first set of data is minus the second set of data equals, you guessed it, 0. Alternatively, your alternative hypothesis, that was clever. So mu sub 1 minus mu sub 2 is either going to be greater than, less than, or not equal to, you guessed it, 0. In the state part, you also need to find these things. You need to find your sample mean of your first set of data, your sample mean of your second set of data, see the nifty 1 and 2. You need to find the standard deviation of your first set of data, your sample standard deviation of your second set of data. You need to find your sample size of your first set of data. You need to find your sample size of your second set of data. And figure out what is C, your confidence level, and what is T star. So you kind of got a couple of things. Now this right here, you're also going to need to find your degree of freedom. Now, what's weird about your degree of freedom is, remember, it is equal to n minus 1. However, there are two different n's, and it's not always going to be the exact same sample size because, not every study is perfect. So, in this case, whenever you're figuring out which n to use, you are going to use the smaller sample size. So whichever one has the smallest number, that's what you're going to use. So let's go ahead and jump into plan. So whenever we plan, the first thing that we're going to do is recognize that we're looking at the central limit theorem. The first question is it random? Yes or no? If it's no, then leave it alone. The second part can be either one of these three things. Either the dot plot or the box plot, whatever graph you're looking at, shows no skews or outliers. So I'm just going to put dot plot as good. I know we've talked about that quite a lot. The other one is your sample size of your first set of data greater than or equal to 30, and is your sample size for your second set of data greater than or equal to 30, or does the problem say so? So this is saying that the problem is like, assume all conditions are met, or both data sets are approximately normal, that kind of stuff. For the do, so we did state, plan, do. In the do section, we are going to find the confidence interval using the formula. It's going to be x bar sub 1 minus x bar sub 2 plus and minus t star times the square root, and this is where it gets a little weird, your standard deviation of your first set of data squared over n sub 1 plus your standard deviation of your second set of data squared over n sub 2. And finally, we are going to conclude. We are going to say that we are C% confident that the interval from low number to high number represents the true average of all, and then talk about your population, that, and then your context. The interval suggests that, and then more fun information about your interval and what it actually represents, so actually interpreting your interval. In the next video, we're going to be looking at an example of how to do this. I was thinking about putting the two problems together or putting the example with the notes, but I had to yell at my cats, and so the video took too long. So I'm stopping this video here. Check out the next video for the examples. Thanks.